Hey guys, here is the first formula that I often teach to my students. You know, the SAT leaves out about 24 formulas, 2 dozen formulas that you need that they don't provide at the beginning of every math section. So this is, as far as I'm concerned, the first formula, the one we need to learn right away. Yeah, I call it the degrees inside a polygon formula. And as you can see here, I have provided the formula, n minus 2, the quantity n minus 2 times 180 degrees. By the way, n stands for the number of sides. So let me go ahead and label that for you right away. Now, in the polygon that I've drawn here, the 5-sided polygon, well, we call that a pentagon. And this one is meant to be a regular pentagon. That word is pretty important. In fact, it's so important, I'm going to write it down up here. The word regular means that every angle is the same inside. They're all congruent angles, and every side is the same. So when you use the word regular, that's what it means. You can have a pentagon, a 5-sided shape, that has different number of degrees. Each of the 5 angles has a different number of degrees, and every side length is a different length, but not with a regular one. So here's the formula. N stands for the number of sides. You're always supposed to subtract 2 from that, so we would have 5 minus 2. That would give us 3, and then 3 times the 180 degrees that's here in the formula would be 540 degrees. Now that 540 degrees is split up equally among the 5 angles, of course. So what I'd like to do is show you the next slide I prepared, and here is that slide. So as you can see, we have our friend, the 5-sided pentagon, sitting on top of a straight line. And I want to remind you, there are 180 degrees above a straight line. One way to picture that is just half a circle, right? This is like a semicircle. You would complete going all the way around the circle. That would be 360. So they're 180 degrees above a straight line. And we're being asked to figure out the value of x. Well, you can't figure out this angle if you don't know this angle. So that's where the formula, degrees in a polygon formula, kicks in. If we recall the formula, n minus 2 times 180 degrees. We use the 5 as we did in the last slide. You'll remember it was 3 times 180, which is 540 degrees. But now we actually have to do the math. We have to divide by 5 because we want to figure out how many degrees there are in this angle. So we do a little bit of division, and it comes out to 108 degrees. Now let me tuck that in. Put that in here, real small print. This is 108 degrees. Well, that angle, along with x, is supplementary. Supplementary meaning it has to add up to 180 degrees. The 180 degrees that we spoke about as being the number of degrees above the straight line. So we subtract to isolate x to get x all by itself. And we're left with 72 degrees, that x equals 72. And that's it. Believe it or not, that problem is actually considered fairly hard on the SAT. It's given a medium difficulty rating, which means approximately half of the students in America can't get it right. The other half are getting it right. But we want to be in that 50% that's definitely getting this right every single time. Okay, so here's our last slide today. We have a square, a pentagon, a hexagon, and last but not least, a nonagon, a 9-sided shape. Yes, it really is a 9-sided shape. So I have this slide here because I think it's really important to know where the formula n minus 2 times 180 comes from. So I'm going to use this square. I'm going to take this one vertex right here, and I'm going to put a point, and a point at that vertex, a point at that vertex, and finally a point over here at that vertex. And I'm going to draw a line to every other vertex in the square, always starting from my original vertex. So when I draw my first line in, let's see that here. It's going to go from here straight on up, right? But then we have another line coming over to here, and then we have a final line going to there. So what you're going to notice here is when you have a four-sided shape, like this square, you will see that there are two triangles inside, okay? Well, with a pentagon, when we play that little game with the straight lines, and we start from this vertex, I'm not going to draw the one that follows the side, but I'll draw these guys. You notice that we have a five-sided shape, but there are three triangles hidden inside. With our hexagon, starting from here, going to all the vertices in the picture, you can see we've broken it up, this six-sided shape, into four triangles. And do you see the pattern? Of course you do. We seem to always be lagging behind in the number of triangles by 2. There are 2 fewer triangles than the number of sides of the shape. I bet you can predict how many triangles we would be able to draw inside of the 9-sided nonagon. Any predictions? Of course, lagging 2 behind. 7 triangles. Now, the formula works because of that lag. You have to subtract 2 from the number of sides. And why do we multiply by 180 and not some other number? Because every single triangle that you have has 180 degrees inside it. So, look at any shape. A decagon is a 10-sided shape. Subtract 2 from it, the answer would be 8 times 180. So this was just a quick demonstration of where this really important formula is derived from. I think it will aid memory. It certainly aided mine when I was first learning this formula. And I wish you luck on test day recalling it. I think it'll be easy, and it will help you raise your scores.